So today I'm going to talk about linear dependence and independence of functions. So in order to find linear dependence, we're going to check to see if two functions can be multiplied by some constants to sum to 0, and that would mean that they're linearly dependent. So we have some constant 1 times f of x plus some constant 2 times g of x equals 0. Now these could be any constant. It could be 1. Now you can rewrite this with a little bit of algebra to say, f of x over g of x, or vice versa, is equal to some constant, which is a combination of the other two constants, but it's still a constant. So if one function divided by the other is a constant, then it's linearly dependent. So we could do an example. So we have the function f of x is equal to maybe x squared, and then g of x is equal to x. So using the first test, think about c1 x squared plus c2 x equals 0. Is there any constant we can multiply by these to get 0 from these? So if we had something like -1, well, that's still going to sum to, there's always going to be that x squared and that x, or there's going to be like just x squared, unless they're both 0, but that's not an option. So obviously these are going to be linearly independent. And let's try it. So we have x squared over x. Well, that's going to be x, which is not equal to 0. So they're linearly independent. That's easy to do with two functions. And we have two functions here. If there's more functions, let's say f of x is equal to 4 g of x is equal to x squared, and q of x is equal to e to the x. So this example, you could do a combination of more than one function. So you could have, let's say like 4x squared plus e to the x, but that doesn't work. So let's try let's try a different method. So another method we can use is called the Wronskian, and I quite like the Wronskian because you can just use it every time. So a Wronskian of some function is going to be just the determinant of f of x, g of x, and then you have f prime of x, g prime of x, put together like that. And so in order to solve it, let's try a function. So we can say f of x is equal to x squared, g of x is equal to x. So our Wronskian is going to be x squared, x, 2x, and 1. And now in order to solve the determinant, we're going to do x squared times 1 minus 2x times x. So we get x squared minus 2x squared, which is equal to -x squared. Now, with a Wronskian, what you want to check for is if it's non-zero. So a non-zero function, so if w is not equal to 0, it is linearly independent. And if it's equal to 0, it's dependent. So you can do that for bigger functions as well, which makes it very convenient. So we can do the Wronskian of 3 functions. So we could have like maybe x, 3x squared, e to the x. And you just have to do it in 3D. So we have x, this is going to be 1 and that's 0. We have 3x squared, we have 6x, and we have 6 e to the x and e to the x. Now in order to solve these, there's a few ways you can figure out a determinant if you know any linear algebra. The easiest method, I think, is just to memorize, so if we had this determinant, a, b, c, d, e, f, g, h, i. Well, we can break it down like this. So I'll move that over. Move this over here. So we have a times e, f, h, i minus b times d, f, g, i plus c d, e, g, h. So just to highlight, so this determinant here is made up of this part and this part. You can see that. Oh, sorry, wrong boxes. These two. There we go. So it's what we do is we cross out the row and column that the A is in and use the rest. And then it's negative B. So sometimes you'll see illustrations with cross-outs and pluses and minuses, which you can use for larger functions, but I prefer the smaller ones. So we can plug these into there and solve that, which I can show you the setup. So we have x times the determinant of 6x e to the x, 6 e to the x minus 3x squared times the determinant of 1, 0, e to the x, e to the x. That's going to be plus e to the x, 1, 0, 6x, 6. And then breaking down these individual Wronskian or individual determinants, it's going to be x, 6x e to the x minus 6 e to the x minus 3x squared, e to the x minus 0, or just e to the x, plus e to the x, 1 minus 0, which is e to the x. And then we could simplify that. But, yeah, so as long as that is not equal to 0, it's independent. Let me know if this helped or if you have any questions. Thanks.